Alright, let's talk about additive versus multiplicative reasoning. We'll start off with the definition. So additive reasoning is looking at the absolute change between two quantities. So when you use additive reasoning, we compare the quantities using subtraction. When we do multiplicative reasoning, we're looking at the relative change between two quantities. When using multiplicative reasoning, we compare the quantities using division. Both kinds of reasoning are important and valuable in various contexts. As a math student, it's beneficial for you to be aware of your own thinking. Are you thinking additively or multiplicatively? Is it appropriate to do one but not the other? Or can both be appropriate ways of thinking? Let's look at an example. We have 3 broomsticks. A red broomstick that's 3 feet long, a yellow broomstick that's 4 feet long, and a green broomstick that's 6 feet long. How much longer is the green broomstick than the red broomstick? Well, you could look at that additively, and you could say, well, the green is 3 feet longer than the red, because you could do 6 feet minus 3 feet and get 3 feet. If you look at it multiplicatively, though, you say the green is twice as long as the red. So you can see the difference between the additive comparison and multiplicative comparison. Let's try some more. How much longer is the yellow broomstick than the red broomstick? Additively, you could say the yellow is 1 foot longer than the red, because you could do 4 feet minus 3 feet. Multiplicatively, though, the yellow is 4/3 or 1 1/3 times as long as the red. So you would put the yellow in the numerator, 4, and the red in the denominator, 3. Here's another one. Same broomsticks, new question. The green broomstick is how many times as long as the yellow broomstick? So think about that. The green broomstick is 6 feet long. The yellow broomstick is 4 feet long. I'm not asking additively anymore, only for you to look at these multiplicatively. Then the yellow broomstick is how many times as long as the green broomstick? So in other words, reversing those, does that change your answer? It should. Think about it. All right. Did you get these answers? The green broomstick must be 1.5 times as long as the yellow broomstick, because the green broomstick is 6 feet long, the yellow broomstick is 4 feet long, so 6 divided by 4 is 6/4, which would simplify to 3/2, or if you want to write it as a mixed number, it would be 1 1/2. So the green broomstick is 1 1/2 times as long as the yellow broomstick. On the other one, the yellow broomstick is how many times as long as the green broomstick? You need the reciprocal of our original fraction. So this time you're going to go 4/6, or 2/3 times as long as the green broomstick. Really make sense of that. The yellow broomstick is shorter than the green broomstick, so it's not even one whole copy. So we only want part of a copy, so 2/3 of a copy. Here's another one for you to try. Let's compare the yellow broomstick to the red broomstick, and the red broomstick to the yellow broomstick. Also think about why we wouldn't need to mention feet in our answer. Alright, so the yellow broomstick is 4/3 or 1 1/3 times as long as the red broomstick. And the red broomstick is 3/4 times as long as the yellow broomstick. I hope you got those right. Why didn't we mention feet? Some people would say their feet simplify, so feet over feet would simplify. But it's really because we're thinking multiplicatively, not additively. If we were subtracting, the units would stay there. We could say 1 is 1 foot longer or 2 feet longer, and so on. But when we're saying this many times as long, then we don't use units. Here's another example. Sue and Julie were running around a track equally fast. Sue started before Julie. When Sue had run 9 laps, Julie had run 3 laps. How far had Sue run when Julie had run 15 laps? Is this scenario additive, multiplicative, or both? There's 2 ways you could look at it. So if you look at it additively, they're running at the same rate, but Sue starts first, so she's ahead. She has a 6-mile head start. There's a table there, so it keeps track of Sue's miles. So when Julie arrives, Sue is already ahead. So Sue is at 9 laps when Julie is only at 3 laps. But notice then they're running at the same rate. If you look at it multiplicatively, you might say, oh, Sue is running 3 times as fast as Julie, and you might make a different table. But if you really think about this, it makes a lot more sense to think of this additively, since it says they're running equally fast. So thinking of it multiplicatively does not make sense in this case. Let's look at a couple more problems. When Lisa turned 2, James was 6. How old will James be when Lisa is 6? Is this scenario additive, multiplicative, or both? Here's another one, which was a more significant change. And support your reasoning. A group grew from 4 people to 12 people, or a club grew from 20 members to 75 members. So when Lisa turned 2, James was 6. How old will James be when Lisa is 6? Is this additive, multiplicative, or both? This is definitely an additive scenario because they each gain 1 year at a time. James isn't growing at twice the rate, right? Aging at twice the rate. So I made a little list there. Lisa, first she's 2, then she's 3, then she's 4, then she's 5, then she's 6. And then James also increases just by 1 year at a time. He doesn't age differently. So James will be 10 when Lisa is 6. Which one is more of a significant change? A group grew from 4 people to 12 people, or a club grew from 20 members to 75 members? You could think of it additively, or you could think of it multiplicatively, but probably multiplicatively makes more sense in this case. So 75 is over 3 times as large as 20. It's almost 4 times as large. Whereas the group who grew from 4 to 12 is just 3 times larger.